Well, hello again and welcome to the VK60S Amateur Radio Channel. I've been doing a bit more with this power board. I went to the Hamfest yesterday in Perth and bought myself a couple more of these capacitors. These 1000 microfarad 450 volt capacitors. Now remember, I put the capacitor clamp in the top left hand corner there and said that I'd put a spare capacitor in that, and I just tacked a resistor across it, so I've got a spare capacitor and a spare resistor just in case I wanted to up the HT voltage at some point later. I've got the identical components, so all I'd have to do is just put that in line, and then just wire that onto the bridge. Now, I got these wire wound resistors here as well. Now, fortunately, when I bought these two capacitors from the Hamfest yesterday, I got the 220k, 4 220k resistors that go with them. So that's two across each capacitor to balance them and bleed the HT down when the power supply is turned off. Now, I've been umming and ahhing about whether to fit those or whether to fit just one larger type resistor, and I got some 47k 10 watt resistors, which are these things here, and I thought I'd see how I go with those. And what I should have done, of course, was sat down and calculated it. I thought 47k 10 watt resistors, yeah, they'll be fine. I can't remember if I did calculate it actually, but I might have calculated it and thought that it wasn't a huge amount of dissipation. But anyway, they do get a bit warm, so my options are put a fan in there to keep them cool, or replace them with higher value resistors, and I think I'm going to replace them with higher value resistors. Whether I use two, whether I use one, it's going to be about 100k. I think I'll double the value. So initially I was going to have only 7 capacitors, and that one as a spare, simply because I thought, well, okay, I need remember, with capacitors, when they're in series, you divide the capacitance, assuming they're all the same value, of course, by the amount of capacitors, and you multiply the voltage working by the amount of capacitors. So with these, I've got 7, so it's 7 times 450 volt equals 3150 volts working. That's with 7 of them, and that would give me they're 1000 microfarad each, and would divide that by 7, which would equal 142 microfarads. So that smoothing there is 142 microfarads, and it's 3150 volt working. Now, because that's not a huge amount of headroom, that 3150 volts, I'll just show you. I'll just move this over to here and zoom in on the metering. Focus. Okay, I'll apply some AC. And just see how close that is to the maximum voltage that's going to appear on the power supply. Okay, it's 1000 volts. That's 2000 volts. That's it flat out. Now the mains voltage goes up and down a little bit here. It was a bit closer to the top of the scale a little while ago. There's probably a few people getting a bit chilly and putting their heaters on. And I've got the high voltage probe here, so I'll just see what voltage. That's saying probably just under 2900 volts, I would say, because remember these the markings on the scale. So that's 2000, then 2200, 400, 600, 800, 3000. Okay, and I'm beginning to sound like that guy from South Park, aren't I? Okay. That's saying 2890 volts. It was 2900 and something a little earlier, and it was 2920, and it was 2980 a bit earlier than that. So I think as people are coming home and turning the heaters on, the mains voltage is going down 10th Street. Okay, let's check that again. Yeah, 2,890 volts, which is pretty good, very accurate indication there for my front panel metering. Okay, now I did actually wonder about putting, this is 1mm building wire, and over here I'm putting the probe on. That's the top of the bridge there. I did wonder about putting a little loop on there with the 1mm building wire, just so that the tip of that probe would go into the loop, and it would just be, you know, it would just be a nice convenient way of sticking it in the loop there, and just put a little bit of pressure on it and it'd stay there. As you can see, the probe's moving around a little bit. But okay, so that's fairly close to my 3,150 volts, isn't it? So if we call that 2,900 volts, that's 250 volts of headroom, which is less than 10%. Not by much, but you know, 300 volts of headroom would be better. So I'll just wind that off. You can see that's coming down a lot faster than it was. So if I put that other capacitor in series, if I put the other capacitor in, what am I going to have? I'm going to have 450 volts multiplied by 8, and that equals 3,600. So I'd actually have 700 volts of headroom. I have a lot more headroom there, and it would be 1,000 microfarads divided by 8 would equal, and I'd have 125 microfarads instead of 142. So I'd be losing, if I put the other capacitor in, I'll be losing 17 microfarads and be gaining 450 volts. So I think what I'll probably do is I'll probably wire this capacitor in, that one there. Rather than have it sitting there as a spare, I think I'll wire that in. And again, I'll change those resistors. I'll get this bloody power board finished one day. But those resistors are, so if we wanted to work out how much power the resistors are dissipating, we'll say that's 2,900 volts. So I equals V over R. So first thing we need to do is say, okay, we've got 7 times 47,000. That equals 329,000. So that's the total resistance of the 47k resistor string across the capacitors. So we want what was it, 2,800. So 2,800. Let's call it 2,900. 2,900 volts divided by 329,000 equals 0.0088. Okay, so we'll round that up, we'll call that 9 milliamps. Okay, so 9 milliamps. I'm going to have to stop saying okay. Blimey, that sounds terrible, doesn't it? Where was I? So 9 milliamps, right. So the power in each resistor is going to be the voltage drop across each resistor multiplied by the current. So the voltage drop will be, so the voltage drop, so that's going to be equals, V equals I times R, doesn't it? So 47,000, hang on, so 47,000 multiplied by, what did I say, 0.009 equals 423 volts. So we're getting 423 volts across each of those resistors, and the power dissipated will be 423 multiplied by the current. So that's times 0.009 equals, yeah, so 3.8 watts. Okay, so if I put 100k resistors in there, that would be divided by 2, 1.9 watts. I think that would be a lot happier. You know, 10 watt resistors dissipating 2 watts. I think will be the way to go. So I think I'll change those. I think I'll change those resistors and wire the other capacitor in. But anyway, it's getting there slowly but surely. I think it was certainly worth trying the 47Ks. It's a shame I didn't get the bloody calculator out before I bought them. Maybe I did, I can't honestly remember. I might have said, well, you know, 3.8 watts, 10 watt resistors, it's no big deal. But, you know, I had the power supply running for about 10 minutes and they do get rather warm. So, don't really want stuff in there getting warm, you know. A little bit warmer than I would like anyway. Not that there's anything wrong. I mean, they're well within specification and they probably run like that forever. But I just like it to be a little bit cooler. And as you can see, the HT voltage has bled away fairly quickly this time. My anode current, my plate current voltmeter has gone back to 0. So that's and the string of resistors here, string of resistors there for the dropping the voltage for the plate current. The voltage meter is sorted out. I think that might have been done on the last one actually, but there might have still been a little bit of a bird's nest there, but I've just tidied that up. So there we go. So the next time you see this, that top left hand corner capacitor will be wired in. I think I'll drop the capacitance, I'll up the voltage, I'll think about it, but yeah, I think 2,900 volts, and earlier when the mains voltage was a bit higher it was very close to 3,000, and you know, with only 3,150 volt working on the bank, I think just a little bit more headroom would be a good idea. So there we go. I'll probably have to, you can see where I've soldered the new resistors in. I've taken the previous ones out, but I've actually left the I didn't change the wiring. So you can see this the copper wiring here. Yeah, you can see the sort of solder in the middle where I've taken the previous resistors off. But what I might do is, if I'm going to put the other capacitor in, I might just rewire the whole bank. I don't like keep heating it up with the soldering iron, but I might rewire the whole bank with building wire again, so that and then put the higher value resistors in, so that there's only solder where they actually connect to the bits of wire. That looks a little bit. I mean, it looks okay, but it if I looked at that, I'd say, oh. Someone changed something there. I'm sure you know what I mean. Alright, well, as usual, it's the wrong way. That's pretty usual, isn't it? Thanks for watching, and I'll catch you next time.